a blast unlike any other. Somewhere deep in the vast silence of the universe, something extraordinary unfolded, something so colossal it sent ripples through the very fabric of space and time. In a corner of the cosmos, invisible to the naked eye, a mysterious event erupted with such ferocity that it outshone entire galaxies. Not for a blink, not for a moment, but long enough to force astronomers across the globe to stop and ask, what on earth, or rather, what in the universe, just happened? This wasn't a supernova. It wasn't a black hole merger. It was something far rarer and far more powerful. They're calling it an ultra-long gamma-ray burst. Normally, gamma-ray bursts are some of the brightest explosions known, lasting only a few seconds. But this one didn't fade away in a flash. It blazed for minutes, an eternity in cosmic terms. And during that time, it unleashed more raw energy than our sun will produce over its entire 10 billion year lifetime. That's not an exaggeration. It's a mind-bending truth grounded in data. Just try to wrap your head around it. Imagine every atom in your body, every beam of sunlight you've ever felt, every bolt of lightning or volcanic eruption on Earth. Multiply all of that energy by trillions, and you're still not even close. That's the scale we're talking about. Scientists say this blast was so massive it may have briefly altered the space around it, warping light, disturbing the flow of matter, and revealing aspects of the universe we're only beginning to comprehend. And the best part? This was just the first clue. The real mystery is only beginning to unfold. From the edge of time, this monster of a burst traveled billions of light years to reach us. That means we're looking at an event that occurred when the universe was still in its cosmic adolescence, perhaps just 2 or 3 billion years old. In that sense, it's like peering into a time capsule sent across the universe, a ghostly echo of a cataclysm that took place long before Earth even formed. The photons from this explosion have been hurtling through space for eons, finally arriving here to whisper their ancient tale into our most sensitive instruments. But here's the twist. This blast didn't behave like anything we've observed before. It didn't follow the typical patterns of known gamma-ray bursts. It was longer, much longer, brighter, and more layered in its emission profile. Its energy signature was chaotic, yet oddly rhythmic, almost like a pulse. This anomaly is exactly what has scientists buzzing. One of the leading theories is that it was caused by the collapse of a supermassive star at the end of its life. But not just any collapse. This could have led to the formation of a magnetar, an ultra-dense, hypermagnetized neutron star that spins rapidly and releases energy in violent outbursts. These cosmic monsters are among the most exotic objects in existence, and they defy many of the rules we thought applied to stellar death. And yet, there's a growing school of thought that this event doesn't fit even those extreme parameters. Could this be the first observed instance of a new kind of stellar death? A type of explosion born from a star too massive to become a black hole, but too chaotic to become a neutron star. Or perhaps, just perhaps, this is a clue to a missing piece of the cosmic puzzle. A hint at a form of energy or matter we've never encountered. Something that could transform how we understand the birth of black holes, the life cycles of stars, and even the timeline of our universe. This explosion didn't just travel across time and space. It brought with it 1,000 new questions, and we've only just begun to ask them. Why this changes everything. Events like this don't just make headlines, they make history. They force astronomers to go back to the drawing board, to question decades of theoretical frameworks, and to ask whether we've misunderstood something fundamental about how the universe works. This single, staggering gamma-ray burst has the potential to revolutionize our understanding of stellar death, extreme physics, and the cosmic mechanisms that drive high-energy phenomena. It could reshape our models of how stars evolve and collapse. It might require us to revisit what we think we know about the formation of black holes, the structure of neutron stars, and even the role of dark energy in fueling violent cosmic events. Space agencies and observatories are already proposing new missions to scan the skies for similar anomalies, hoping to catch more of these events in real time. We could be on the edge of a paradigm shift in astrophysics. But what's most intriguing is what we still don't know. Why did this burst last so long, far beyond the standard gamma-ray window? Why was it so powerful, exponentially more energetic than any previously recorded burst? And perhaps most tantalizing, is it part of a larger hidden pattern in the universe? A cycle we've only just begun to glimpse? If more events like this surface, we may be standing at the brink of a new cosmic era, one where the rules of energy, matter, and time as we know them might be rewritten. And you're watching it unfold in real time. Could there be a deeper message? Now, we're not saying it's a message, but when something this rare and extreme happens, it's hard not to wonder, is the universe trying to tell us something? Could some cosmic bursts actually carry hidden information, patterns, data, even signals? Some researchers have proposed that deep within the gamma-ray chaos, there could be encoded rhythms, tiny shifts in frequency or intensity that aren't just random, but deliberate. Think about it. What if these bursts are nature's way of transmitting information on a galactic scale? A universal language we've only just begun to detect? We know from quantum physics and cosmology that the universe is full of hidden order. Patterns repeat at every scale, from the spiral of a galaxy to the spin of an atom. So it's not impossible to imagine that gamma-ray bursts, these violent beacons in the dark, might follow a code, something we've yet to decipher. There are even fringe theories suggesting that these could be the byproducts, or even intentional broadcasts, of hyper-intelligent civilizations far beyond our own. Signals not meant for us, perhaps, but picked up by us as we eavesdrop on the grand dialogue of the cosmos. Sound far-fetched? Sure, but every great discovery once lived in the realm of speculation. We don't have those answers yet, but we're listening. And with every new burst, every signal, every unexplained anomaly, we get one step closer to decoding the deepest mysteries of the universe. Share your theory. So what do you think this explosion really was? Was it just a dying star's last breath? A glimpse into the early universe? A new type of cosmic event we've never imagined before? Or could it be something even more extraordinary? An echo from another dimension, a ripple from the multiverse, or a deliberate attempt at interstellar communication? We want to hear your wildest, most imaginative theories. Drop them in the comments. Don't hold back. Maybe it's something only your unique perspective can uncover. After all, some of the greatest scientific leaps began as questions no one else dared to ask. Could this burst be a repeating event? The first of a hidden cosmic pattern? Might we be witnessing a rare natural phenomenon? Or the signature of an ancient technology light years beyond our understanding? Your idea might sound crazy today, but tomorrow it could be the seed of a new theory. So let's explore this mystery together. Let's crowdsource curiosity. If you're fascinated by the unexplained, by science that borders on science fiction, and by the awe-inspiring forces shaping our cosmos, don't just watch from the sidelines. Subscribe, hit that notification bell, and become part of a growing community of cosmic explorers. Because this explosion might not be the last. It might just be the beginning of something much, much bigger.